Hello all, welcome back to the session. So the topic for today is tools, memory and ReAct. This is continuation of the topics which we did yesterday, correct? So yesterday we had a deep dive into LLM and LangChain. So today's agenda revolves around a small recap of LangChain and agents, and then go for tools, learn about ReAct agents, and learn about memory patterns and storage, memory storage and patterns, correct? So it majorly focuses on three major topics: tools, memory storage and patterns. So yesterday we learned about LangChain and we learned why LLM is not enough, correct? Along with LLM we require agents which can do some processing before sending it to LLM, and it can also do some processing after getting the result from LLM, correct? So if you see the LLM layer, it goes and calls chains. Chains is basically import LLM and output, which is again given to agents, tools, memory and retrieval, correct? So it can take tools. Tools are external calls. We discussed that tools can be database, tools can be API, tools can be files, anything, correct? Which is then followed by memory and which is then followed by retrieval. We also learned that in our examples, Olama provides the local LLM runtime, and the ReAct orchestrates the reasoning and tool actions, correct? So how the agents work: the user queries, it goes to a agent reasons. Based upon the reasoning, it will select a tool, execute it and observe the result, and in the observe it will again give a thought to the result and give the final answer, correct? So this is a loop, is the core of ReAct. So now why tools matter? Tools are very important with respect to any agents, majorly because tools solves what we call as hallucinations, correct? So hallucinations are results which are not expected by the customer, which are not data based, correct? So that problem is easily solved by using tools, as tools are responsible for giving the result from a data source which the user intends. So LLM alone cannot perform this task. LLM will need access to API, or it needs to run some other code, or it needs to search data, read files, get from some data store, correct? So agentic called tools strategically make use of ReAct, correct? ReAct. So first question comes, why custom tools? So standard tools like search, math, they are very good. They can do lot of things. But the actual value of agentic AI will come when you connect agents to your business logic, correct? So when you connect your agents to your business logic, then only value will come. For example, a customer who wants to know the balance, for this particular example, you need to connect the customer to the actual data source, correct? Then only the answer will be happy. Same applies for any user who wants to see how many mutual funds he or she has, correct? So that information will of course come from the broker in which they are storing this mutual fund, correct, or the demat account. So the value for users in such cases will come from the data storage, correct? So here you will get the full benefit only and only if you are able to make use of LLM, and you can make use of LLM to use the data from the data store, correct? Now, so what are the standard data stores? It can be an internal API. It can query database, SQL databases, NoSQL databases, any types of databases. It can also perform actions like send emails, update Jira, and so on. Or it can also run individual algorithms, correct? So one of the one of the things which is becoming very hot in market today is automated trading, correct? Algo trading, automated trading. So in such cases, you will want the LLM to run your proprietary algorithm. Of course, you will not expose the algorithm to LLM. You might give an API through which the LLM will be able to call that algorithm, and based upon the results of the algorithm, it will show you the results, correct? So, so you see more and more famous tasks or objectives are achieved by combining LLM with custom tools, correct? Yes. So how can we define custom tools? We define custom tools with the help of @tool decorator, correct? So Langchang uses function name, hints, and doctrine to generate schema that tells LLM when and how to use this tool, correct? So LLM has that brain to decide when to use this tool, correct? What it also implies is there can be more than one tool available, and based upon the need, the corresponding tool can be called, correct? Yes, LLM has that capacity also. So, so with tools we get the actual benefit, and you will be able to make use of tools, and you can also make use of LLM to the maximum only if you have ReAct, correct? ReAct, as the name suggests, it's reasoning and acting. So the agent loops allows the LLM to think before it acts. User wants inventory, for example, this is an example. So user wants an inventory for item 123. So the action will be called, which is actually a tool call, which will call a function check inventory, which will check the inventory for item 123. Within this code, we will write the code to look up the database and get the quantity and give the final answer in a way which any user can easily understand, correct? So you see, the agent is thinking, and based upon thinking, it is taking action, and whatever result it gets, that result is polished in such a way that the end user will like the answer, correct? So that's the entire foundation of ReAct, correct? So the entire foundation of ReAct is to present the realistic answer to the user in such a way that they will feel humanly. Okay. So reasoning and acting. So we learned all this. Now along with this, many times we may want a conversation history, correct? So the next question which I asked should be related to the question which I asked before. Now this is very true, especially if you are doing coding agents, correct? So in coding agent, the next step should be determined by the previous step, correct? Every time you don't have to give a brief or a full summary of what all you are expecting. So you can divide your task into small parts, and based upon that, you should be able to, or the agent should be able to continue with the request. For example, if you are dealing with any API, you want to design an API in any programming language, first thing you will do is define a function on top of its annotate with the corresponding annotations. Then you will say that within this function, it should go and call the database. Then you will say that the database name should be this, and it should, the table name is this. So can you create entities? Can you create queries? And then can you connect so that it becomes an end-to-end flow, correct? So we will require a conversation, and when we want to maintain a conversation like this, we require something known as conversational history. So how can we maintain conversational history? So conversational history can be maintained with the help of memory. So how many types of memory are given? One is short-term memory, one is long-term memory. So short-term memory are memory in which we store only n number of messages, correct? So only the last few messages we will store. So you are limited by a context window. Within that context window, whatever you use, you will get. In the long term, you will have a entire data store for your historical conversations, correct? So this will make it much easier to go to any conversation and continue from there. Okay, so there are two types, short term and long term. In long term, we generally make use of vector store. We know vector store, we discussed about it yesterday. So using vector store, you can store your conversation from textual to vector form and retrieve it easily. That process we called as embedding, if you remember. So from memory and retrieval perspective, we have short term and long term. Okay. So now question comes, what all different patterns are supported? Okay, so the memory, so we learned that to store any history, we require either memory or we can also go for storage. So the first pattern which we are learning is in-memory buffer. So in memory buffer, you will be able to store the conversation in a typically in-memory data structure. A very common data structure in Python which we use is either list or dictionary, correct? So you can see the mechanism stores all the messages in Python dictionary during a program runtime. Of course, the problem with this approach is if you restart, if the program gets restart, which is storing, your historical context is gone, correct? So what use cases it will help us? It will help us for quick testing, simple chat interfaces or sessions that do not need to persist after the server shuts down. As I told you, if the program restarts, then your context is gone. So it cannot be used for super critical activities, correct? Yes. Now, within LangChain, you have functions like runnable with message history, which can automatically maintain the message list, correct? So what we want to indicate here is LangChain provides us with some helper classes or functions or modules using which we can maintain this historical data, correct? So how to use that we will see with an example. So this is the first memory pattern. The second memory pattern is file based persistence. In the case of file based persistence, instead of storing everything in memory, we will store it in disk in a particular format, correct? The most common format which we have is JSON. So the advantage here is even if you restart the program, it can continue. Since the session related information is stored, we can recover that from the file and we can move, correct? So the history will survive program restarts. Okay, the use cases are single user chatbots, restarting a demo and so on. Okay, so again, LangChain provides us with ability to store such session related data into file or folder structure, correct? The problem with this approach is you cannot scale beyond certain limit in this approach, correct? Why you cannot scale? Because many operating systems like Unix and Linux have a upper limit on the number of files you can create, correct? So if you create files beyond that, it will not allow you to create any further more files. That implies either you have to programmatically keep on cleaning the sessions after a period of time, correct? Or you have to go for a better storage, like for example in AWS S3 is available. So file storage where you can store as per need, correct? So that's the problem with this file based persistence. So it's not generally very scalable, correct? So you cannot increase it beyond certain limit. But of course, it's better than in-memory storage for certain use cases where you don't want, where scalability is not an issue, but still you want the history to continue, correct? We also have third pattern in which we store the information in a database. That's what we call as database persistence. So the example which we are going to do is MySQL. You can use any database. Now when I say database, database doesn't imply only SQL databases. It also includes NoSQL databases. You can store, you can connect it with Cassandra, you can connect it with Redis, you can connect with any MongoDB. You say the data source, that data source can be easily connected with the help of LangChain. So it provides support for that. I will show you what all connectors it has, correct? So the advantage here is it can scale. So it gives the benefit of SQL or NoSQL, whichever you are using. And you can retrieve the data at any point of time and you have complete control of the data, correct? So that's the advantage this pattern gives you. So using database persistence, you can persist anywhere, correct? Okay. So with this much information, let's go and see our practicals, correct? So what I will do is, I will have to first start Docker desktop and then go and start our Olama. Perfect, it's starting. So let's say Docker start Olama. Okay, so Olama server is started. Same way, I will also have to start. So if I say Docker ps -a, I will also have to start my database, but that I can do later on. For the first examples, we require only our systems, correct? So if I go and see, these are the memory based examples which we have. Okay, so let's go and see what all it provides. So we are using LangChain and I am chat Olama. Same way, within LangChain core, we have prompts. We have chat prompt and message placeholder. If you remember chat prompt template, you know it's used to modify the input in such a way that LLM can easily understand. We also have support from LangChain core runnables history, where we have a class runnable with message history, correct? So this allows you to run a context with history. And we also have chat history, which has base chat history and in-memory chat history. So in-memory chat history is the corresponding helping classes which helps us in storing the information in memory, correct? And LangChain core messages, human message and AI message, this we used yesterday, correct? And we also are using dictionary and any. That's just for typing. As you know, Python is a data loosely typed programming language. So typing is not much helpful here other than understanding, correct? Other than readability. So here you see we have a store. In the store we are using a dictionary. In dictionary we have a string and we have a in-memory chat message history, correct? This function, this object. Now we are calling get session history. In get session history we are passing session ID. So we are checking within the store whether this session ID exists. If it's not there, we create an object of in-memory chat message history and store the session ID as a key and this as a value, correct? And we return the store session ID. So the use of this get session history function is to go and check whether the session ID was already created and available. If not created, it will then correspondingly create a new object and make use of that new object. Yes. So that's what we have written here. Next, what we do is we make use of Chatolama, making use of Mistral model and 0.0, correct? Actual accuracy. Then chat prompt dot from messages. Given system, you are a helpful and friendly assistant. Keep your answers concise. Then message placeholder. Now this is an important step. See, I'm saying that we have to make use of history. Correct? Variable name is history, and human whatever inputs is a parameter. So when you call the invoke method, you will pass input that will be replaced here. Correct? So we created the prompt. Now we are going to make use of LSEL, correct? LCEL, lang chain expression language. Now here we are saying base chain equals prompt, the prompt which created, and LLM which we created here. Correct? Now what we will do, runnable with message history, runnable equals base chain. So I'm giving base chain. Now within this runnable with message history, there is a get session history function, which we are linking to the get session history function which we created. So what does this imply? This implies we can create any function with any name and just link it to get session history key where we are able to relate to this, correct? And input message key is equals input and history message key is equals history. So we are also indicating that what is the input and what is the history, correct? Then what we are doing, we are creating a session ID, a dummy session ID, user demo 1234. In the configuration, I am creating configurable with session ID. Then I am giving first input. So in the first input, you see, you are saying my cat name is something something. What is the tallest mountain on the earth? And we are indicating that user one is firing this request, and this chat with history, correct? Object which we created, we are calling that with first input and config, correct? So the session ID will get passed. So naturally it's an LLM, it will run and give you the response. Then correspondingly what I am doing here, I am asking second question, what is the name of my cat? That's the second input. Again I am making use of chat with history, and I'm giving the second import and the config, and I'm waiting for the response, correct? Same way, what country is it located? The third question I am asking, correct? And what I am doing is just for history check, whatever store within the session ID messages are there that I am printing, correct? Just as a reference. So this is what we are using in the first example. So this is memory one example in which we are making use of in memory chat message history, correct? So let's try running this. So I also create a virtual environment just to make it simple. So we can just activate it. So I'll just copy it. So what is a virtual environment for people who are new to Python? Virtual environment allows you to actually keep your dependencies in a particular session, correct? So whenever you want, you can enable that virtual environment, run the dependencies, run your program, and then you can close the virtual environment. So the advantage here is conflicts between two different projects in the same machine will not happen. For example, if in the same machine, project number one wants LangChain 4 and one more project requires LangChain 3, then these conflicts will not happen, correct? Because each of them are maintaining its own virtual environment. So when you enable a virtual environment and when you start a virtual environment, automatically all the dependencies which are installed within that virtual environment will become active. Okay. So creating virtual environment is very straightforward. You just have to say Python venv and give the name of the virtual environment. Okay. So what I'm going to do is, let me open one more command prompt and run this. So you see the virtual environment got activated. Now what I will do is I will run this memory1.py. So let me copy the path, cls, Python, and run. See, starting the conversation. So you can see the first user put in the question, my cat name is, that user is trying to give information. So you can see the first assistant gave the first answer, and it also made use of the extra information. See, while mittens may not be able to climb it, you can certainly share this one fact with him. And then second question which we are asking, what is the name of my cat? Now, this will come from conversation history, correct? Okay, so total messages in history is 6. Last stored messages, Mount Everest is located in Nepal and Tibet, correct? You're able to see that? So this is how we can make use of this in memory. Overall 6 messages are there in the history for this particular session ID, correct? Which we created. So you see, thanks to LangChain, it provides this helper classes, and all this is available in the latest version of LangChain. If you are using previous versions of LangChain, you will get conflicts. So please ensure you are using the latest version 1.0.4 as of today, which has all these facilities, correct? So this is the first example in which we did everything in memory. So how to maintain conversation history with in memory, which was our memory pattern number 1, we covered here. Okay, hopefully it's meaningful to everyone. So let me clear the screen. Now, as you know, the problem with this memory1.py is as soon as the program ends, the context is gone, correct? So how can we improve the context? We can improve the context with file mechanism, correct? So you see, this is the file mechanism. Again, we are making use of LangChain, run with message history, correct? And with LangChain.chat message histories, we have chat message history. Okay, this class. And so again, we have this get session history, where instead of using in-memory chat history, we are making use of chat message history. The store is again a dictionary, as you can see. So we have just modified the get session history. Instead of returning in-memory message history, to return chat message history. Then we created the LLM, okay, Mistral model. We created the prompt just like the earlier example. So till here steps are same, other than that change chat message history. And we are also creating the pattern base chain is prompt plus LLM. Yes. So now what will happen here is, now as soon as you port, oh sorry, this is not file, this is the second example, which is same as the earlier one. File is here, sorry, my bad. So since we discussed about it, let me just finish this example. So this is chat message history. So this is another class, okay, which it supports. It also mimics a database, correct? Chat message history. So just like in message history, we also have chat message history, correct? It also mimics a class. It gives you the same benefit of um, in memory one. There is not much difference. So it just provides you with this extra helper class. Okay, so working wise it's same. So I'm not running this again because you see everything else is same, correct? So session ID and calling them, running them, everything is same, correct? So it's just an helper class, chat message history. You can either make use of in-memory class or chat message history class, correct? So moving to our actual example, file one. So this is the file example. So here we have the history directory. The directory name is chat histories. If you see it got created. For now, what I will do is I will just delete it. Okay, you see it gets created again. So this is the chat histories directory. So when the program runs, OS is an inbuilt module available in Python. So here I am going and check in whether this directory is present. If it's not present, it will create this directory. Now in get session history, we have the session ID. So what we do, we form a file path using the directory and the session ID.json, and we make use of this file chat message history. This is the helper class, file chat message history. So using this, you will be able to store every session related information in the file path. Then we created the chat alama, the prompt, all this is same, correct? You can see variable name is history, human is input, prompt and LLM, run with messages, all the same. Only difference is in get session history, instead of using chat history or in memory history, we made use of file chat message history, correct? Then once we do that, we will again call. So session ID name is this, we gave user file session 001, history file name is this. In the configuration, I just passed the session ID, correct? And this is my first input, which is what I am calling by using chain with history.invoke. Then we call the second question. Then we call the third question. So when I call the second question, automatically it will take from the file, correct? Now just like we were able to read data from in memory, we can also read data from file chat message history. I give the history file and I get the messages, and I show the second last message and the last message, correct? This is what we show here. We can run this. Python paste. So here, instead of using the normal in memory, it will load into sessions. So as soon as you run, you will start seeing that folder getting created. So refresh. It will create and run. You will see that folder getting created. See, history saved to the file. Order. That. It's within memory. Memories. Yes. So total 4 messages were stored. Refresh. If you refresh, you will be able to see the JSON, everything. Making this, I don't know where it can be, what part we have given. Let's see, created history directory. Chart history. It created actually. The thing is, I'm not able to see it. In the directory, you'll be able to see the JSON and all. Anything C users Vishwa. It has generated there. So if I go to C users Vishwa, I ran it from there, so it should have created there. What was the directory name? chat history. So you can see it got created here because I ran the program from there. That's why you see time also matched. So if I open this user file 001, see you're able to see the JSON. So each question, what all it evaluated, it has stored. Fully everyone able to see. So this is how it stored the data. So next time when you run, it will automatically get the data from here. Correct? Hopefully that makes sense. Since I ran the program from C users Vishwa, that's why the folder got created there. We can control the place where we want the folder to create by giving the complete path. Correct? So you can see this is how we created. Hopefully that makes sense, everyone. If you want, I will open that same JSON file in VS Code. See, this is the JSON file. So type, human, data, content, everything is stored. You see, additional type human, then type AI, what AI responded back. That also it's stored, correct? Yes, so it becomes quite easy for it to handle this. So this is the way this works. Yes. So using that flat file chat message history, we'll be able to retrieve based upon session ID and make use of the file for answering the questions related to the user per session, correct? Hopefully that's clear, everyone. Yes. Similar to this, we can also create in memory. In memory, we decided database, correct? So, of course, I have given my username and password. In real world, you will try to encrypt it and keep. So we have this Olama chat history table. So what I will do is, let me connect to my DB. You can say, come here and say Docker start my DB. Okay, and I will connect to that Docker PS Docker exec minus it slash bin slash sh. This will connect to my database MySQL minus u root minus p root minus p and give the password as root. So I will create the database. It should be already there. So databases. You can see there is a database with name LangChainDB. Okay, so just for your convenience, let me create again. Drop database LangChain underscore DB. So I'm dropping that database so that I can create again and show you from scratch. So create database LangChain underscore DB. Okay, so use LangChain underscore DB. Now I have to create a database table structure. So the table structure of the database is like this, correct? See, Olama chat history ID is int auto increment session ID. This is very important. So the unique identifier that groups messages in a conversation, correct? And message which is text. And we are creating index on the session ID because session ID is not the primary key. So we are creating an additional index so that it becomes easier for it to query. Okay, so if I copy this and create the table, come here, have to paste it. So table is created. So if I say show tables, select star from Alama underscore chat underscore history. See, it's empty now. So now let's go and see what programmatically we will have to do. So first, if you see, I am making use of this LangChain community chat messages history, SQL chat message history. Okay. And along with that, I will also have to make use of SQL Alchemy. So that's a library using which it's an ORM, correct? It's equivalent of ORM, which can connect to any database. So the table which we are naming is Olama chat history. Now you are free to name it anything. So I named it Olama chat history. I am creating my JDBC URL by using this MySQL user, my password, host name, port name, and database name. So in the get session factory, I am making use of session ID. So here you can see I am creating SQL chat message history in which I am passing session ID, I am passing the connection URL, and I am passing the table name. And I am initializing chat Olama. As usual, I am creating the prompt, the input message, prompt and then passing to LLM. I created the chain. And then I am saying runnable with message history. In runnable with message history, in runnable, I gave the base chain, I gave this guest session history. You see, in all the examples, the most of the places or the only place where we are changing is this get session history, correct? The first case we made use of dictionary. In the second example, we made use of in the first example we made use of dictionary with that in memory object, a message history object. In the second one, we made use of the file based message history object, and now we are making use of SQL chat message history object, correct? So here runnable with message history, I am calling the get session history, input and history objects. Then I am giving this as the session ID. In real world, the session ID is generally generated by your server code, correct? So if you are using any server, like for example, if you are using Django or Flask, you can create session. That session ID will be remembered till that session ends, correct? So I'm printing that session ID. I'm saying start MySQL based conversation. I pass this session ID. User's first question will come. Then second question will come, and third question will come. And each and every time we are using the session ID, correspondingly it will get dumped into database. And in the history manager, we are using this get session history and see number of messages. So total messages from the MySQL table and the last response we have printed, correct? So let's run this. So what I will do is just running Windows CLS. Yes, and run this example. Okay, so let's see how it fires. So as you can see, as soon as we are firing the query, you will start entries coming into database. You see already two entries have come. The same thing, JSON data gets stored here now. Conversation history gets stored. And finally, when you run everything, it will show total messages in the MySQL table is 4. If you go and fire that in the query also, select star from now. See 4, it came. So 4 records have been stored, correct? Yes, so this is more better because at any point of time you want to look, it becomes quite easier given all the benefits of database, correct? All the benefits of database. Now here we made use of SQL. Similarly, there are many others which are offered. So if you want to see them, what all is offered, you can go to this. So if you see the virtual environment within lib, you will be able to see this LangChain community chat. So if you go scroll down, yeah, LangChain community. Within that, if you go and see chat messages history, within that, if you go and click on this innate, you will be able to see this all type of what you can say integrations are supported. See, it can integrate with Cassandra, it can integrate with Cosmos DB, it can integrate with Astra DB, Elasticsearch, file chat, which we used, correct? Firestore, yes, if you are using Google Firebase, you make use of Firestore. Chat message history, which we used. Kafka, it can also store on Kafka, it can store on Momento chat, MongoDB, Neo4j, graphical NoSQL, correct? Postgres, Redis, again Redis. So if you want high speed performance, more speed than database, then you can go for Redis, correct? Speed is very important when you consider Redis. It acts like a cache. Rocket chat, SQL chat, which we used, correct? TADB, you see there are many options which are available with various integrations, correct? So all these type of integrations are provided by this LangChain community extensions, correct? So as I promised you, I showed you what all extensions are there and what all you can integrate with, correct? So that finishes all our memory patterns. Hopefully everyone clear with that. Now we can also, since we are learning about tools, let's also see what all tools are there, correct? So in this example, what we are doing is, in this example, we are connecting to an external API and getting data from there, correct? So what I did here was, I am making use of this URL. I don't know whether this URL still works because this URL is quite slow. So, question mark ID equals Canada. So ID is coin ID. Bitcoin. So if we go here, one sec. So it's not a reliable API, but it works certain times and it doesn't work. But our aim was to show that it can be integrated with tools. So that's the only thing. So if I go here, API, crypto API, this one. I will have to make use of the API key. So I am showing the example without API key, but you can create the API key. Since my intention was to show more on what it does, correct, and so on. So that's what it is. So you have to set up your API key and then you can call this. So what we are doing here, let me show you from example perspective. I have created a get crypto price method. So this method takes two things. One is the coin ID and one is the currency. Okay. So using the coin ID and currency, we are looking up into this API coin checo.com for a price. So I am passing the coin ID and currency and looking for the price. We are making use of the request modules. So I am hitting the URL with the parameters which is passed, and we are waiting for the response. Correct? So response.json, and whatever data we get, price data, from that we extract the data and print the price data. Correct? And in case we face any error, which we will because we are not passing the API key, it will result in an error. Correct? Now in the tools, I create this get crypto map. Correct? And I am also creating a tools map, which is a dictionary in which I am looping through each and every tool and using the tool.name. So get crypto price, comma, get crypto price, like that it will come. Correct? Get crypto price in string. Now I created the chat olama with Mistral, and we are binding the tools. Correct? Binding the tools. And from chat prompt.message, we are saying that you are a financial assistant. You are going to make use of the get crypto method. Correct? Price method only when asked for specific coin price. And here we give the placeholder for the messages. Then we create the chain. First prompt will come, then LLM with tools will come. So you see, I am binding this LLM with these tools, which is an array. Correct? And then we are running manual agent, which takes user input. So in the messages, it's a list of messages where I say human message with content user input, and using the runnable, I invoke messages message. Correct? So naturally it will go through prompt, then it will go to LLM, and we are just printing. Correct? If the AI message did not call tool calls, then it will say directly answer from LLM. Else it will go through tool calls. Correct? And print what tool it called with what arguments and what it got. Correct? So we are just printing the output of what it came in the tool message format and append in it, and then we are running final result. Whatever result was returned by the tool, we are calling by using messages. In runnable itself, I am a message. So if it's an AI message or tool message which comes, it will format that message and give us in a respectable format. Correct? So the major aim here is to show you that this get crypto price function gets called. Correct? When you ask for a price. Now after all this formatting, we are running it. What is the current price of Cardano ADA in USD? So this ADA becomes the coin ID, and let's pass that. I don't know, it doesn't work without this T, but still let's check. Explore documents. It's become completely slow over the past few days. Let's copy that URL. Space artists. What's the URL? This was the URL, so let me copy this. Two params it expects. Let's give that params and see what it gets. So the results ID equals ADA. Yeah, it's not giving any result. Maybe because of the API key. But nevertheless, we will just hit it. If it doesn't give, correct? So let's say it gets updated every 5 minutes. Yeah, JP, for JP it comes. So let's just convert that to JP and see. But it's not guaranteed, it gets updated every 5 minutes. So let me just go and update the question with JP. Okay, so let's see. Let's run this. Go back. Crypto price checker. Copy the path. Go here. Clear the screen. And say Python. Crypto price checker. Let's see how it runs. I think it will take 2 minutes. Let's wait. See the output. See, it's showing all the steps. LLM requested one tool call. So the tool call went. All the value from Cardona. Local Ulama is running. Yes. See, it gave the result 0.4294. You're able to see it is able to get that result from there. Now, then I asked second question: what is the primary difference between a cryptographic currency and a fiat currency? Now, here we are not asking any price difference. We are asking a generic question. So let's see whether it calls tools. So what we want to show in this example is you have made your agent smart enough to decide at which part should it call tools and which part it should not. That's the power which comes here, correct? And let's wait for a minute. Yes, if I go up and see, it didn't show the steps like what it showed earlier. LLM requested one tool execution success, send in tool to result, nothing, correct? If you see the second one, it directly went and gave the final AI response. Everyone able to see that? So you see, that's the power of this mature AI agent, correct? So based upon the question, it can decide. You see the call of the function is same, run manual agent, but here we are checking whether the call should happen through tools calls or not, correct? And based upon that we answered, correct? Yes. So that's the way it worked. So this is a very good example. As you can see, we are able to fire and get the response from actual API. Till now we were mocking the data in all our examples, but here we are getting it from the actual API, which is what makes this example quite good, correct? And one more thing we learned, that tools can also be a list. You can have any number of prices like this, correct? And we were very clear that get crypto price, this should get called only when user asks for a, correct, your intelligent finalization, use the get crypto message only when user asks for a specific coin price. Yes, it's very clear. So that's the advantage of this. Hopefully this makes sense. So you see, we are progressing in our way of agent making. In the first day we just learned that agent is a theoretical concept. In second day we learned about LLM. In third day we learned about LangChain. Now you see everything is coming together to form our first agent, which is actually connecting to an API, getting the results and showing the results, correct? So you see we are moving fast track into this agent creation modes, correct? Okay. Now a few more things which we want to discuss is medical records, correct? So in this example of medical records, we are simulating or emulating medical records of patients, correct? So you see these medical records as patient ID, date of visit, diagnosis, medication, and notes, correct? Just like a record, it's having. Now what we are doing is we are making use of the document object which is available, and we are calling that, correct? Calling document page content equals record, medical records. So we created documents. In coming few days, we will also see how to make this from PDF or Word or Excel files, correct? That will come. For now, assume that we have this data. Now what I am doing is I am making use of this recursive character text splitter. This is a class given to us by LangChain text splitters, and the role of this is to split the documents into smaller manageable size, correct, which is very much used by RAG, correct. So chunk size 500 and chunk overlap 50, these values I gave. And using test splitter, I split the documents, correct? So this doc becomes that. Now we all know this doc is all in textual data. So we will make use of Olama embedding. We used it yesterday also. Olama embedding. And using nomic embed text, which is a model available, we will be able to convert that to vector store, correct? So if you remember yesterday also we did this example by using FAISS. From documents, docs, and Olama bindings, we created this, and we are using vector store as a retriever, correct? So here we are saying k equals to means retrieve the top two results. Now we are creating the chat Olama object, LLM object. This is the ReAct prompt. We are saying you are a highly specialized medical assistant. Your task is to accurately and concisely answer the question based upon medical records provided in the context only, correct? And we are very clear, since this is very sensitive, do not use external knowledge. And we are saying if the information is not in the context, state that explicitly, correct? Then we form the context and we form the question. In the chart prompt dot from template, we are given this RAG prompt template. And again, we are forming the rank change, correct? In the rank change, I am giving context, retriever, which is our vector store, then runnable pass through the question, then RAG prompt, Olama, and finally the output we are storing in the form of str output parser, correct? Now, first question come, what medication is patient currently taking and what condition? So if you go and see, that's there, P1001, correct? So it will search here, get that record and show, correct? Yes, Olama answers is this. What is the recommended dosage for penicillin? Correct? Querying outside the context. So we'll have to see what happens. And we are again invoking ratchain.invoke query outside the context, correct? And see what output it gives. So this is our example. So let's copy this. Open a new command prompt. And say Python. Paste this. This is querying from the document store which we created and giving the results from there. Correct? Since it's running in our local Llama, it will take a couple of minutes. See, it gave him complete information. Based upon the product medical record, patient is currently taking metformin. Additionally, he is also taking silicobin. So if I go and see the data which we had originally, yes, P1001. See metformin. You're able to see that? It was able to understand that. And silicobin. This also printed that result, correct? Now we are asking the second question, which is outside the context. See, the information was transferred in such a nice way. See, there is no data on penicillin. Therefore, I cannot provide any answer to this question. See, perfect answer, correct? Which we expect as per medical records. Okay. So you see, we can also tune our system to answer based upon our behavior, correct? Our expected behavior. So now in the second example, now in the first example, actually we just created a dummy records, correct? So in the second example, I am going to read it from a CSV. So I have this medical.csv. So if I go and show you here, this is the CSV. So you see, this is the CSV. That's the same information: patient ID, date, diagnosis, medical, and vitals. Correct. So now I want to make use of this CSV instead of creating dummy data. Okay. So here, if you see within LangChain community document loaders, we have this CSV loader. Okay. So using CSV loader, I am loading this CSV file and giving delimiter. I am saying documents equals loader.load. So this will load all the documents, correct? Then again, I am using recursive character splitter, which will split based upon our chunk size. We will split the documents. We will do embedding. We will put it in the vector store, correct? Then we created the Llama model. We created the same context and question, and even the rack chain, if you see, is same. Only thing the retriever now is actually CSV retriever, correct? So what condition does patient have related to joint planes? It will query that CSV files and find the corresponding answer and give, correct? So what were the vitals for Alice Smith? So using rack chain, we are able to do that, correct? So let's try running this. So this, instead of loading from the plain memory, it will load from a CSV file, correct? So this will read from that CSV file correspondingly and get the details from there and answer. So here we are, here one CSV file. We can also have group of CSV files or folder of CSV files from where we can look up, correct? See, give the information. Give source is this, page is this, patient ID content is this, and information based upon the provided patient as chronic joint pain as stated in the document, correct? What were the vitals for last checker? Again, this will check from the CSV file, get the data and show. Let's wait for a minute, it will show the results. See, it gave blood pressure is this much. Perfect, correct? See? So everything came from that CSV which we had used. 120/80. Agreed? Now, within within our agent, we have something known as metadata filtering. So what happens in metadata filtering is, based upon this extra data, it will now see, we all agree that the data source can be enormously big and it can also have categories, correct? So when a question comes, if a question is related to a particular category, then lookup should happen only in that category, correct? That's what we call as metadata filtering. So metadata filtering is, how can we attach a metadata so that when we search, the LLM runs only on the required data, not everywhere, correct? So again, as you can see, we are using documents, FIS, the dependencies are same. So here we see we have the trial docs, correct? So in the trial docs, we are making use of page content, investigation drugs, phase 1, and what is its effect, correct? By using Olama embeddings, we create a vector store. And in the vector store, we are saying search k request, k equals 3, filter equals phase 1. This is the key filtering step, correct? Phase 1. So this only retrieves documents where phase is equals to phase 1, correct? So we are limiting that. Then using chat olama and from template, answer questions based upon context. We are passing the context, the retriever. And here we are saying summarize the findings of phase 1 regarding drug Y. Correct? So this is the user query. We will use it in drag chain filtered, and that result we will print. So here only the data related to phase 1 will come. If any questions you ask about phase 2 or phase 3, it will not come. Correct? So this is what we call as metadata filtering. It allows you to filter data. See, you see, this will ignore phase 2 and phase 3 regardless of semantic similarity. So you can metadata filter based upon the nature of request. Correct? So let's try running this. Right here. Let's say see, it gave proper output. Yes, so this is what we call as metadata filtering. Okay, so that's also a pattern. Let's go back to the slideshow. So tool calling agents, we did that, correct, with Python, where we actually called a live data API, got data from them and processed the output, correct. We made use of the tool decorator, correct, correspondingly. So this is an advanced pattern. This is called as tool calling agents, where we actually add the agent calling a live API and get the data from them, correct. Meta filtering, which we told. So in meta filtering, we will filter the data based upon or narrow the search, correct, basically. Yes, so metadata filtering involves applying structured constraints like dates to the documents stored in vector database before the vector similarity search is done. So even before similarity is done, you are restricting based upon certain criteria, correct. The major intention of this is to limit the search space and improve the retrieval accuracy, correct. Again, by doing this, you will prevent hallucinations. Okay. So you see, first a query will be there, a vector query will be there, and metadata filter will be there, correct. Yes. So vector query is used for semantic search, metadata filter is used for narrowing the data, and based upon that, the result will be given, correct. We already saw that in phase 1. So along with metadata filtering, you will also have to give vector query, correct. Author equals Joe Dow, and year is 2023, correct. So that is metadata filtering. So in metadata filtering, common use cases will be temporal filtering based upon time, security access. Certain times, certain users will have only certain data access, correct. So based upon access only, it will be allowed you to see the data, or else it will be rejected. Source or source type control, correct, based upon from where you are getting and what are your rights, or state management, correct. So metadata filtering is very helpful for giving accurate results. So now one famous question which comes is, what is the difference between metadata filtering and semantic search, correct? So metadata filtering is exact match on a structured criteria. The criteria is there, it's present, you are put in an exact match. In semantic search, which is the vector search, we are using that cosine similarity, correct? If you remember, to measure the distance, correct? In metadata filtering, we make use of Boolean logic. In the case of semantic search, we make use of distance metric like cosine or Euclidean, correct? So the data types are string, numbers, booleans, dates, lists. Here the data types are vectors, embeddings, correct? And in metadata filtering, we have guaranteed precision on attributes. Here it returns relevant documents, correct? So these are the differences. So metadata filtering is equivalent to database search, but semantic search is based upon mathematical values which lie within that range, correct? So it's a famous interview question. What is the difference between metadata filtering and semantic search, which we wanted to show what's the difference, correct? So question for time for few questions which are asked in interviews. Question number 1, describe the trade-offs between using chat message history, which is in memory, versus file chat message history for production. So what do you think? Correct? Which one should we use? The right answer to this question is based upon the need of the app, correct? So based upon the need of the app, we will decide whether we have to go for chat message history or file chat message history. If speed is a concern, we will always go for chat message history, correct? It is fastest because it's in memory. Non-persistent, it's non-scalable. So that also we have to remember, correct? File-based is persistent. It is slightly slow as compared to in-memory and not suitable for high concurrency. So high concurrency means more number of users, correct? So when more number of users come, more number of files will get created, and it can cause race conditions in certain operating systems which are based upon Unix and Linux. Because of the restriction from the operating system itself on the number of files which can be created in a directory, this can cause issues, correct? So which one will you use? Naturally depends upon your app. Both of them have their own advantages and both of them have their own disadvantages, correct? So second question is, if you were designing a large scale multi-tenant chat application, which LangChain history class would you choose and why? Example, SQL chat message history or Redis chat message history. See, the difference between SQL chat and Redis chat is the underlying storage. So in SQL chat, the underlying storage is SQL, which is a database. Database is something in which data is arranged in the form of tables. Of course, database follows all the ACID properties as atomicity, consistency, isolation, and durability. So as compared to Redis, it will be slightly slow. Correct? Redis, on the other hand, can operate in memory or disk storage, but it's relatively very fast as compared to SQL. Correct? So if speed is your concern, then you will always go for Redis. Correct? But if you want something which is more normalized, more clean, which is persistence, which is very, very accurate, you will go for SQL. Correct? So data integrity, reliable persistence, Redis is low latency, high concurrency, and caching that. So for a large scale multi-tenant chat application, multi-tenant means more than one user, correct? So, and large scale chat application. So chat is on the fly, speed is very much accurate. You can go for Redis. And we can divide Redis. Redis also supports partitioning. You can use that, correct? As an answer. In a retrieval augmented generation system, explain the differences between semantic search and metadata filtering. We did it in a complete tabular form. Why do we need both? So why we are doing both? In our example also we did both, correct? First we filtered based upon phrase, then only we applied semantic search. The reason for applying both is to save time and to increase speed, correct? If I search on all semantic search and get the results might be unwanted and it will be of course slow, correct? Because you are searching on a large amount of data store. So when you do metadata filtering and search on the semantics, you might get a better results, correct? So, and so certificate documents are both relevant, correct, and authorized, correct? So these are the advantages of using both semantic search and metadata filtering in one. Okay, so let's see what all we learned today. So I think we learned a lot today. So we started again with LangChain recap. Then we went and learned about how agents work. What are the significance of tools, correct? Today we also practically saw how to use tools to actually make a API call, get the result, and pass that result to LLM to massage that result and show to us in a format which will look more humanly, correct? We also went and learned about ReAct agents, correct? Agents which will think both at the input level as well as the output level before taking actions. If you remember, the best example for this was again crypto only, where only questions related to currency went through tools and others did not go through tools, correct? So it gives the agent a capacity of deciding which call should go where. Then we went to memory store. In memory store, we saw the options of storing in memory. We also saw how to store it by using files and SQL, correct? So we learned all the three options which are supported, how they are supported, the corresponding classes as per the latest version of LangChain, correct? And finally, we also learned about patterns. We learned a couple of patterns from medical records. We learned how to give only the relevant information, correct? And we also learned how to read from a CSV file and give the relevant information. And we also learned about metadata filtering, which will filter out based upon semantics before filter out based upon conditions before applying the semantic search, correct? So that's the patterns which we applied overall. And we also created a application of agent, correct? Complete application of agent. So till now, what all theory we learned, we applied it in the crypto example. I will just go through that example once more. So if you see the crypto price checker, we created this crypto price input which expects a coin ID and currency, correct? And we created this schema. If you remember, a base model again we used yesterday also, today also we are using. It comes from Agentic. Then in this get crypto price, we are making use of coin ID and str, and we are also saying in the argument schema should be crypto price input. So why we are giving this? This is because so the LLM knows that when it's going to call this method, it has to pass the coin ID and currency. So based upon the question from the user, it will automatically come to know that it has to use this schema as a reference and give the parameters. Then we saw it went and hit this API, got the data from this API, and when it got the data from this API, it passed the data, correct? It returned that data. So then in tools, we made use of this get crypto price and we created the tool maps. We made use of the Olama model, the LLM model. And in the LLM model, we have this bind tools method which binds to these tools, correct? In the chat prompt template from messages, we strictly told that only question in which we have price, you should go for this, else no. We created a chain. Then run manual agent. Here we fired the human message and we made use of runnable.invoke. So when you say runnable.invoke, it will go through this chain. It will first go to the prompt and then LLM with tools. And based upon the result, we also checked whether the tool calls happened or not. If there is no tool calls, we are just returning back the message. In case tool calls happened, we are getting the result, arguments, and whatever value came from that tool map we called, and that message we formatted, correct? Again by using AI, and that result was shown. So when we asked the question of JP, we were able to get the data from there. And when we have asked the difference between cryptography and fiat currency, you saw it did not went to tool call itself, correct? So based upon the nature of our request, it was able to make automatically extract the parameters, put the parameters and run. So this is an actual example of a mini agent, correct? Of course, this can be expanded to any level. Hopefully everyone clear. This is also known as hybrid example. Same thing like what we are shown here in hybrid. Now here hybrid is one more example where it can combine. So one more example which I want to show is, you see here we have two types of files, policy docs and procedure docs. So policy docs are all the policies, procedure docs are technical procedures, how to do, correct? By using Ollama embedding, I create two vector stores, one for holding policy, another for holding procedure. These are two variety of docs, correct? We can also have aggregate context. In aggregate context, I am using policy context and procedure context and combining them as combined context. Okay, and I return the combined context. Now in the RAG, we are saying that you are an expert assistant. Yes, and if it is not present as a part of this context, you can do. You will not answer, correct? So using the chat prompt, we generate the input, then we create the Ollama model. Then in the hybrid change, we give the context, we give the question, we give the RAG prompt, Ollama model, and the output. If I need to reboot the server, how long it will take? So now this comes from hybrid, correct? So it's combining both this context, and on the combined content, it can search, correct? And give the result. So this example shows that. So what this example shows, you can create an aggregate context which can combine data from two different data sources, and based upon that use it, correct? Okay. So you can run this also. Let me show how to run this. So this example shows how can we combine data from two different data sources, correct? Combined in that context, it can give you the result. See, it is given. So the single question answered from both the context. So we can also combine context like this. Straightforward, you just make use of the retriever and combine the context, correct? In a combined context once. So that's the way we are able to use. So this is what we learned today. Hopefully you're all getting together on how agents work and how to go forward for developing agents. We are moving more closer to create more complex agents, which we'll see in coming up days, and take it forward from there. So thank you so much everyone for your time. Hopefully you all enjoyed this session. We will again catch up tomorrow to learn something. Thank you.